We have few identities which we'll be using in trigonometry. Let's start with some. Number one is tan theta is equals to sine theta over cos theta. Number two is sine square theta plus cos square theta is equals to 1. We have been using these in AS also, and where we know secant theta is equals to 1 over cos theta, cos secant theta is equals to 1 over sin theta, cot theta is equals to 1 over tan theta. Third identity would be 1 plus tan square theta is equals to secant square theta. And fourth is 1 plus cot square theta is equals to cosecant square theta. Formula sheet will be given, but it is good if we memorize them. Now let's try some of the examples. It says cot theta plus tan theta is identical to secant theta cosecant theta. Give it a try. So we know that tan theta is sin theta over cos theta. On the other side, if it is cot, it would be reciprocal of that, cos theta over sin theta. And when we take the LCM, this is sin theta times cos theta and cross multiply cos square theta plus sin square theta. And we know cos square theta plus sin square theta is equals to 1. So this is 1 over sin theta cos theta, where 1 over sin theta is cosecant and 1 over cos theta is secant. So we take them in the numerator. Cosecant theta, secant theta, you can rearrange secant theta, cosecant theta. Left hand side is equals to right hand side. We have one more identity to practice. This is cos A divided by 1 minus tan of A plus sin A divided by 1 minus cot of A. And we have to show that it is identical to sin A plus cos A. Now as we can see that left hand side is more expanded than right hand side, so we'll go with left hand side, and we have to convert all of them into sine and cos. So I have to disappear tan and cot. In order to do that, cos A over 1 minus, I have to disappear this tan, so making it sin A over cos A. On the other side, we have to disappear cot, that is 1 minus cos A over sin A. Now when we take LCM, this is cos A in the numerator and for the denominator cos A is the LCM, and we cross multiply. This is 1 minus cos A minus sin A. On the other side, sin A in numerator and LCM is sin A again, cross multiply. This was 1 by 1, this became sin A, the other is minus cos A. Now we simplify these two and this goes in the numerator, becomes cos square A divided by cos A minus sin A plus sin square A divided by sin A minus cos A. Now see, we have almost same denominators but the sign is different. So I'm taking out this negative sign as common. So writing cos square A over cos A minus sin A. If I take out that negative sign as common, I'm left with sin square A, and in the denominator this will become cos A minus sin A, as I took negative sign out and changed the sign of denominators. Now I have same denominator and I'm taking LCM, so this becomes cos of A minus sin A, and in numerator I have cos square A minus sin square A. Using the identity we get cos A plus sin A into cos A minus sin A. This is the identity, A square minus B square equals A plus B into A minus B, and denominator was cos A minus sin A. You get rid of these two and finally we get cos of A plus sin of A, and we had to prove cos of A plus sin of A. Clear? Quadratic form. So this is secant square theta plus tan square theta is equals to 6, and we have our identities. We can use this. Secant square theta equals 1 plus tan square theta. So I'm replacing this secant square theta with 1 plus tan square theta, and tan square theta again is equals to 6. Now this is the quadratic form. We rearrange, add these two, you get tan square theta, and on the other side 6 minus 1, 2 tan square theta is equals to 5, tan square theta is equals to 2.5, and tan theta is equals to plus minus square root 2.5. Now we find the basic angle. So alpha is equals to tan inverse square root 2.5. We always find the basic angle with the positive values, and we get an answer of 57.7 degrees. Now we know that we had theta in both positive and negative, so it can lie in all the quadrants, but we will always be given with some domain, some limit. Suppose the domain is 180 degrees is less than theta and theta is less than 180. So we have these two cycles in which we can answer, and theta is positive, negative, so it lies in all 4 quadrants, which is add sugar to coffee, all positive, only sine positive, only tan, and only cos positive. So if this is 57.7, my first angle would be theta is equals to 57.7 degrees, and second angle would be all the way till here, so 180 minus 57.7 for the second angle, which is 122.3 degrees. For the third angle, let me say this is the third angle, so that is straight away negative 57.7 when we go clockwise, and so on, negative 122.3. One last line and we can rearrange them. Negative 122.3 degrees, negative 57.7 degrees, 57.7 degrees, and 122 0.3 degrees. Any confusion? Another question. It says 4 cos square theta plus 5 sine theta is equals to 3. Now we know that sine square theta plus cos square theta is equals to 1. So I can replace this cos square and convert all the equation into sine. This is 1 minus sine square theta plus 5 sine theta is equals to 3. If I make cos the subject, that is 1 minus sine square. So 4 minus 4 sine square theta plus 5 sine theta is equals to 3. Rearranging, taking this on the other side becomes 4 sine square theta minus 5 sine theta plus 3 minus 4 is equals to 0. So 4 sine square theta minus 5 sine theta minus 1 is equals to 0. Now we have to make factors of 4 into 1 and 5. So this is a quadratic equation. If we can go through midterm breaking, find other than that we can use quadratic formula. So minus 4 sine theta, 4 into 1, we'll have to go through quadratic formula. I'm not getting perfect numbers. So that is minus b plus minus square root b square minus 4ac over 2a, where b is minus 5 plus minus square root minus 5 squared minus 4, a is 4 and c is minus 1 over 2a. Let me use calculator. I'm getting over 8. With positive sign, I'm getting sine theta is equals to 1.43 up to 2 decimal places, and with the negative sign I'm getting negative 0.17 or 18 up to 2 decimal places. So we solve for them individually, and alpha for the first case is sine inverse of 1.43. And sine inverse 1.43 is rejected. If you remember in AS you did these graphs that sine theta lies within 1 and minus 1. So it is outside 1 and minus 1, so it is rejected. We solve for only sine theta is equal to negative 0.18, and we always solve with the positive number for the basic angle. Basic angle is equals to sine inverse of 0.18, that is 10.36, so approximately equal to 10.4 degrees. Now we knew this angle was negative. Add sugar to coffee, and sine is negative in third and fourth quadrant. And this is 10.4, this is 10.4. So first angle is all the way till here, that is 180 plus 10.7. Theta is equals to 180 plus 10 point, sorry, that was 4, so 10.4, that equals 190.4 degrees. And the last one is 360 minus 10.4, that is 349.6. degrees. Any confusion? Okay, so cot square theta could be written as cos square theta over sine square theta. On the other side, we have cosecant, which could be written as 1 over sine theta. Now, as we have sine theta on both sides, we can get rid of this power, and this is cos square theta divided by sine theta is equals to 1. So cross multiply. Correct. So 1 minus sine square theta is equals to sine theta. Now we rearrange, take all of them on right hand side. This is sine square theta plus sine theta minus 1 is equals to 0. Now we can use quadratic formula for this. So minus b plus minus square root b square minus 4 a c over 2a, and we have 0.618 or negative 1.618, which is again rejected as it is outside 1 and minus 1, and using 0.618, alpha would be sine alpha is equals to 0.618. Basic angle is sine inverse 0.618, and alpha is equals to 38.1. Now we knew it was positive, so it has to be in first and second quadrant. So theta is equals to 38.1 itself, and 180 minus 38.1 to give the second value, which is 141.9 degrees.